remind everybody that starting Friday, we will be teaming in every day. Okay? Or every Monday, Wednesday, Friday, we'll be teaming in. Because after Monday, I will be, Friday will be a test day. Monday, we don't come to school. And then by Wednesday, I'll be helping my son with virtual learning at home. So that's when Wednesday technically is the first day we'll be teaming in. Friday is a practice day. And Monday, we don't come to class. And Wednesday is our first official teaming in. That's not practice. Okay? All right, so I'm going to say n is equal to, let's make it a 7. And so we've got, let's go with some test scores. Let's go with 75, 78, 78, 80, 85, 88, and 92. How many is that? 1, 2, 3, 4, 5, 6, 7. There we go. Okay, now I want you to go ahead, and I don't care how you do it. You can do it on your calculator if you want to. I'd rather you do it by hand, because this whole Excel spreadsheet is to try to do everything by hand. So take your calculator and find the mean, median, and mode of those 7 numbers. I'll go over here and I'll put mean, median, mode, range, mid-range, variance, and standard deviation. Now, again, and I'm going to add the 5-number summary on that. Mean, median, mode, range, mid-range, variance, standard deviation, and the 5-number summary in the box plot. That's 90% of chapter 3, except for z-scores. So if you can do what I'm doing today by Friday of this week, you've got 90% of chapter 3 done. So hopefully y'all remember how to find your average. That's going to be equal to the summation. Wait a minute. There we go. The summation of all these numbers divided by what number? 7. Thank you. And everybody should have that number. Now I'm going to leave the digits to 5 or 6. I would suggest you do the same thing with your calculator. So that way at the end of the problem, you can have a true number to round with. Do not round in statistics. You do not round in the middle of the problem. So somebody going, oh, well, that's just 82.3. Then you're going to get the answer wrong on a test. And it's just going to be a rounding. You leave 82.2857, at least 4 digits. Leave that in your calculator. So you might want to go into, let's see, where is the, I don't know what y'all have at home. Well, hello. There we go. But you want to hit, where is the configuration? Well, a mode, there we go. Turn it on first. Hit mode. And leave it on floating if you want to, but if you want to make sure you get at least 4 digits, then you hit 4. and hit enter right there. I'm not going to do it because I want mine to be on float. Okay, so make sure you set your calculator to do that. Second, quit. Go. All right, median. Oops, I spelled median wrong. The median is equal to, since it's odd, since this is odd, I'm going to highlight that yellow. Since 7 is odd, I'm going to count 3 down, and boom, there is my median. So my median is equal to 80. Mode is 78, isn't it? Now, I'm going to highlight 78. I'm going to highlight that a real light pink color. Because I want you to realize that that number is observed. It is not calculated. It is observed. So if you don't have a mode, you just put NA does not exist. There isn't a mode. There isn't none. Whatever you want to put. Do not put 0. Range. That's going to be equal to the highest number minus the what? Minus the lowest number. Mid-range. That's the average of the range. So that's going to equal the highest plus the lowest, or the lowest plus the highest. It doesn't matter. 2 plus 3 is the same as 3 plus 2. Divided by 2. Now, at this point, I'm going to highlight these 3 right here. I'm going to highlight these 3, those 2. I'm going to highlight those 2 kind of a verde, and this one verde. Now, somebody tell me why I highlighted those 3 green. Why did I highlight those 3 green? Anybody want to take a guess at it? They're important, but tell me why they're important. The mean, median, and mid-range. You need to write this down because this is important in your notes. Why are those 3 highlighted green? Anybody want to take a guess? Anybody from home? You can type it in the chat if you want to. Why? Hold on a second. Let me see what that is. Chat. Where's that chat coming from? Well, somebody's chatted, but I guess it's not in this class. Does anybody want to tell me where they think it's coming from? Or why that, I'm sorry, or why those 3 I highlighted green? They're important, yes, but why are they important? Because they are all forms, write this down, all forms of a calculated center. C-E-N-T-E-R. They are all forms of a calculated center. And what is important in statistics? The center. So if all 3 of those numbers are somewhat close to each other, what does that mean? That means that your normal curve is existent. If these 3 numbers are somewhat close to each other, then that means that your normal curve, that's what you have. Let's put 105 right here. And watch those 3 green numbers. Now they're going crazy. Let's put a 42 right here. Look at them. Okay? Now, why didn't the median change? Well, the median didn't change because it's observed in this case. 7 is an odd number. So the median is observed. Okay? Because you don't have to calculate anything. But look at the range, the mid-range and the mean. They're going apart from each other. And you notice the mean is more than the mid-range and less than the median. So you start to see, Always. If you start putting numbers in there, it's kind of crazy. Now watch what happens to them when I take those off. Let me hit undo. Where's undo on this thing? Can't see the top of the, there it is. Now look, the original numbers we started with, and look how close they are. If these three numbers are close, that's good. That means you got data that doesn't have outliers or crazy things, okay? Variance. Well, before we start with the variance and standard deviation, I always like to go to the book at this point. Let's see if I can pull up the book. If somebody has a book and they can tell me where they go into the, well, this variance and standard deviation, I think it's like 3.2. Somebody help me out if somebody's got a book. Yeah. Okay. So let's go to, well, chapter contents, 3.2. Now, the reason I want to go to the formula for variance, I want you to see it as it's printed. I don't want you to think that I'm making stuff up, okay? So let me go to, I'm trying to get there. There we go. That's not what I want. Why can't they do something without confusing students? Why can't they just do that to begin with? All right, so here is the mean, the standard deviation formula right there. Now the variance is this right here. The variance is what's inside. So write that, right? S is equal to the summation of x minus x bar, quantity squared, divided by n minus 1. I want you to write that down. And I'm going to, let's see if I can, no, let's see. No, I'm not going to be able to. Well, I might be able to. Let me snip. Okay. SN. There we go. Let's go with snip. And new. Save. Standard deviation. Pictures. Save. Now let's go to our handy dandy Excel spreadsheet and insert pictures. I just amazed myself. There we go. So now we got that in there. Why did I bring that in here? Why did I bring that into the Excel spreadsheet? Because you need to read the formula as we do it. Now the variance right here is all of this stuff right here. Okay? And the standard deviation is the square root of the variance. Write that down. The standard deviation is equal to the square root of the variance. Or you can just put, standard deviation is equal to the radical, and then put VAR up under the radical. Okay, so let's just find the variance, because if we find the variance, then all we got to do is take the square root of the variance and we'll have the standard deviation. So somebody tell me, what do we do to get that? I want y'all to read that formula right here, and somebody tell me what we're going to do. And I'll just mention that every one of these numbers, that number, that number, that number, that number, that number, that number, and that number, those are x's. Okay, so what are we going to do to the x, to each x? Well, that summation, you're going to add something up. What are you going to add up? Can somebody tell me what x bar is? X bar is another word for what? The mean. Okay, and I'm going to give you that little bit of information. Hopefully you can tell me what we're going to do. I'm sorry, I couldn't hear you. Okay, what are we going to do with that x bar? What is that x bar being done with here? In the formula. I'm trying to get students to read the formula. A lot of times students, and I'm talking about in the past, they just look at that formula and they, okay, what do we do? They're not reading the formula. Read the formula. You said that we're going to add up something. Yes, we're going to add up something. That's what that sigma is for. That's what that funky looking E is for. That's correct. But what are we going to add up? What's inside the parentheses? Everybody should be looking at that formula. What's inside the parentheses? X sub I minus what? X what? X bar. So somebody tell me, in layman's terms, what are we doing in those parentheses? Okay, people at home, y'all can type it in the chat or you can speak. I'm not asking, this is not rhetorical. I want y'all to read that formula and tell me what are we going to have to do to get the variance. Okay, what does the symbol between the X's mean?
Right.
Thank you. Here we go. We're making some progress now. We're going to subtract what? Okay, didn't y'all say what X bar? What did X bar mean? Okay, so let's put this together. We're going to subtract the what? From each X. So where's my X's? Somebody tell me where my X's are. So what are we going to do for the first part of this formula? What are we going to do to each one of those numbers? Subtract the mean. Good. So we're reading the formula. I'm going to put a handy dandy, I'm going to put a space right here. And I'm going to call this, and I'm going to put center, and I'm going to put bold and underlined. And each one of these is X. So this column right here, and I'm going to change that to no highlight. This column is going to be called X minus X bar. So equals, I'm going to take 75 minus that number. So I want everybody to make a column besides your x's and take your calculator, and I want you to take 75 minus x bar, 78 minus x bar, 80 minus 8 bar, 85 minus x bar, 88 minus x bar, and 92 minus x bar. Go ahead and do that in your notes right now. This is how you find the variance by hand. I know I'm using the Excel spreadsheet, but the reason I'm using the Excel spreadsheet is so I can get all this on the board at one time. There's no way if I was writing by hand, I would get all this on one board. It'd be a mess. So I'm going to copy that down for y'all so you can check your numbers. Oops, let me lock the F4. There we go. And I'm going to copy that down, and y'all check my numbers, and this will check your numbers. So everybody in your notes should have a column beside X called X minus X bar. Now the reason I type in X bar, X BAR, y'all can use the little X bar with the bar over it. But it's just, I have to bring in a symbol, and it's just easier to type in X bar. Well, for some reason, I don't know how that happened, but somehow our formula got covered up by that bar down here. Oh, that's why I put in a, okay. Does anybody have any questions about X minus X bar? You should be able to finish that up by now. Everybody should have a calculator, so you should have at least the first, the middle, and the last number done. So in your notes, when you get home, you won't be confused on what you were doing. And you can always go back and read the what? Read the formula. X minus X bar. Now, what are we going to do with X minus X bar after we subtract it? What are we going to do with that number?
Square root.
We're going to, not square root, but what's that? We're going to square it. So now I'm going to go X minus X bar quantity squared. And that's, I'm going to take that number and I'm going to square it, and it's going to make it positive. Equals this raised to the second power. Now make a column and do that. I'm going to have to move this here. Okay, so everybody should have those three columns now. All right, Miss Eves, what are we going to do with X minus X bar quantity squared? We're going to add them all up. That's what that funky looking E means. So we're going to put a total right here. And I'm going to color that. Let's color it. Well, that's too purpley. So we're going to color it some form of magenta.
Magenta's a fake color.
A fake color?
Yeah.
It is? Oh, okay. I mean, it's not in the Roy G. Biv, it's not in the spectrum. There we go. And we're going to add all those up. And that number right there in magenta is your numerator of your variance. Now remember, the variance is what's under the radical. So we're ignoring the radical right now because we're finding the variance. So that sigma x of I minus x bar quantity squared, that part right there is equal to 229.428.571. Now I'm going to do this calculation for y'all, okay? N minus 1 is 6. Okay, I did that calculation for y'all. Hopefully y'all can do that in your head. I'm not going to put that on the Excel spreadsheet. So my variance is equal to, and you write this in your notes, 229.428.571 divided by what? Read the formula. What does it say? That means I want y'all to answer.
N minus 1.
N minus 1, which would be what?
6.
6. Now, a lot of you are saying, well, Hubert, why are you making us answer that? Because people will not read this formula. They'll go, okay, I need to find the variance. Hubert, how do I find the variance? Right after I showed them the formula. How do I find it? You got to read the formula. And now that is the variance. Now, what is the variance? It measures how much up and down motion you have in your graph. It's really not important. It's important because now what do we do to find the standard deviation? Take the, no, what's that radical mean? The radical right here.
Square root.
Take the square root. Or raise it to the 1/2 power or 0.5 power. That's up to you how you want to do it. So that's equal to this number raised to the 0.5 power. And that number right there is your standard deviation, which is a very important number. And I'm going to highlight that one a different shade of green because it is not part of the middle. It is more of a, just an important number in general. There we go. Okay, what, say again? Well, this is standard deviation is measured off the mean. I'm going to show you that here in just a second. So I'm going to get rid of the formula here. If y'all don't mind, I'm going to get rid of that. And I'm going to start, I'm going to put the normal distribution curve down here. And that number right there is going to be our mean. Okay, right here. So I'm going to put that in green. And that's going to equal that number right there. And I'm going to go 3 standard deviations to the right. Now, if this is the middle of the number line, like 0, what do you do to the right of 0? Do you add or subtract to the right of 0? You add. So I'm going to add the standard deviation to that number. And I'm going to do it 2 more times. Now, what do we do on the left side of 0 on the number line? Add or subtract? Okay, well, if we add on the right, then what do you think we're going to do? We're going to subtract. So I'm going to take that 82 and I'm going to subtract that. And I'm going to lock it because I want to copy over. And I'm going to copy over 2 places to the left. Now I got to bring up my whiteboard, so I'm gonna minimize this right quick and bring up my whiteboard. What? There we go. Bring up my whiteboard, and then we'll get back to the spreadsheet. Hold on just a second. There we go, new. And I'm going to put a transparency, and I'm going to bring up my Excel spreadsheet, okay? Now, before we go any further, I need somebody to look up in your book, I need you to look up the empirical rule. Somebody look that up. Somebody's got a book, please look that up for me. Tell me what page it's on, because I'm going to be circling through the book trying to find it while y'all are looking. 132. Thank you. I'll just hit arrow. 130, 131, 132. Now I need you to study that empirical rule. I need you to put this in your notes, and I need you to memorize it, because the rest of the semester you're going to be using this. It's called the empirical rule. Let me make it a little bit smaller. There we go. There it is. Now I want everybody to make sure you put that in your notes right now. Draw it out big so you can understand it. Next to the standard deviation and the mean, the empirical rule is probably the third or fourth most important thing that we're learning in chapter 3. Why? Because as with the mean and the standard deviation, the empirical rule is going to follow you with the mean and the standard deviation to the final exam of this semester. So if you choose not to learn the empirical rule, you're basically, cutting off your nose to spite your face. You're basically sabotaging your grade by not learning the empirical rule. Now, you don't necessarily have to write all that that's in the gray box. The only thing I care about is that you understand the picture. So I'll give you a minute or two. I'll give you, a minute to draw that picture also. And a lot of people say that probability and statistics is very difficult. I've had students that had to take it twice and 3 times. Not in my class, they didn't, because I try to explain everything. But you would be surprised on how many teachers can lobotomize students over something as simple as the mean and the standard deviation. It's not that difficult. You add the standard deviation on the right, you subtract the standard deviation on the left. Think of standard deviation, and write this down if you get a chance. Standard deviation is equal to the spread. And write the spread, like, the spread, like you put on a sandwich, the spread. Okay, put that in quotation marks. The standard deviation is equal to the spread. If the standard deviation is large, then that means your data is spread out. If your standard deviation is small, then that means your data is close together. Capiche? How are we doing at home? Do y'all have that picture written down yet? Give me a couple of yays or nays, or put your raise your hand to let me know that you're pretty much okay with it as far as drawing it down. I got 1 hand, 2 hands. Okay, so they've already drawn it. Now let's go back and notice at the bottom. Notice at the bottom of your curve, it says mean in the middle. See that mu? That's your mean. The mean goes in the middle. Mu equals mean, x bar. And what do we do on the right side? We add the standard deviation, add the standard deviation, add the standard deviation. What do we do on the left side? We subtract the standard deviation, subtract the standard deviation, subtract the standard deviation. And that's what I've done with the Excel spreadsheet. So if you take, please work. You have got to be kidding me. They give me styluses, and guess what's not in them? What? You gotta love Tri-County Tech. People at home, Tri-County Tech has given me styluses with no batteries. What? If the standard deviation is large, that means the spread is large. If the spread is large, that means that the numbers are spread out. Your X's are spread out. Come here. Didn't you do me a favor? Can you go downstairs, take this to the lady downstairs in the computer lab, and tell her that we don't have, both of these don't have batteries. And what room is this? No, look outside the door. I think it's 236. Ask her, she's at the desk in the computer lab downstairs, and tell her I need 2 batteries for those. Can you believe they put this system is brand new, and they didn't put batteries in it? Anyway, let's see if I can do this while we're waiting on him, because chances are she won't be down there, and he'll probably either wait or he'll come back up here without batteries. What? Yeah. Okay, and this, don't laugh. There. Don't you laugh. Unless you can draw with a mouse, I can't. And there's your mean in the middle. Everybody with me? That really sucks, Hubert. Let's see if I can do a little better representation here. There. It's not much better, but it's better. Okay, there's the normal curve. Now, there's 3 standard deviations to the left, and I'll draw those. And I'm trying to, just give me a second. There's 1. There's 2. And there's 3. And there's 3 standard deviations to the right. 1, 2, 3. Everybody with me? Now, by the empirical rule, 34%, by the empirical rule, 34%, I'm going to use this, this very bright green, 34% falls, 68% falls within 2 what? 2 standard deviations.
She said you run through batteries.
Did you tell her there wasn't even batteries in here?
No, I just asked her for that.
There was not even batteries in the thing, and there haven't been batteries in it. You can tell there hasn't been a battery in there since they put this in here. Damn Russians. 6%. Do y'all have any idea what 6% is? What is it?
6 out of 100.
No, 6% is what the CDC has just reported. 6% of the population of people, 6% of the dead people that died of solely COVID. The rest of them had ill health. 6%. So that means, oh, shut up, Hubert. Just shut
What
up.
does that have to do with the batteries?
Russians. All right. That's a joke. It's trying to make light of the situation. All right. So 34% on the left, 34% on the right, and that equals what? 68. So you got to learn how to read the empirical rule. Please learn to read the empirical rule because we're going to be using it all the way up to the final exam. And I'm going to show you a trick I learned in the war here in a minute. Okay? All right, so there is 34% on each side. And then 13.5% is, and that's normal. Oh, shoot. Hold on. Let me hit undo. My mouse is acting funny. What's wrong with this mouse? There. Okay, and I'm going to pick another color. And we'll go with orange. 13.5% is right here. And if you don't understand where I got that 13.5, then you need to look at your empirical rule. The empirical rule is one of those things that the teacher tells you to learn, and half the students don't listen, and then they wonder why they're making bad grades later on in the semester. Okay? And then 2.5% falls out here. Okay? So I'm going to take a red highlighter, and I very seldom use red. Okay? And I'm going to draw a red highlight there. "95% of the population," and it should say that on your empirical rule. 95% this board don't work. Yes, you're right. Fall between 2 standard deviations. So frustrating in school, I ain't kidding you. One of these days in 2050, we may have technology and it may be up to date. Anyway, look at there. Did it draw that after I drew it? Whatever. I'm trying to get the board to work, people at home, and it's not working, so I'm going to have to continue with the mouse. It showed up like 15 minutes later. That's good. 95% of the population is what we call normal. And I am writing with a mouse, so y'all do not make fun of me. Okay? 95%, and that's on the empirical rule. 95%, if you add up those numbers, fall within normalcy. What is between the second and third standard deviation? Put a big U here. U stands for unusual. U stands for unusual. So if I made a 96 on my test, that would be unusual based on the scores that I have. If I made a 64 on my test, that would be unusual. And what's outside of unusual? That's your Michael Jordans and your Tiger Woods and your Peyton Mannings or your Tom Brady's. What are they? They're the outliers. Your 6 foot second graders. Your 1800 SATers. They're called outliers, huh? They're called outliers. So if you made 102 on this test, what would that be? That would be an outlier. What if I made a 60 on this test? That would be an outlier. Based on the numbers that we have, the 7 numbers that we started with. Now, I'm going to shut her down because some of y'all are going to go into convulsions. Okay? So let's go ahead and shut her down. I'm going to show you one other thing. Everybody in here can go to Google and you can pull up the empirical rule, copy it, and print it on paper so you don't have to draw it. Now, is this the only time you're going to draw the empirical rule in my class?
No.
No. So chances are you're going to draw it 15,000 times this semester. So I'm going to show you this, and you pull it up at home. Pull up empirical rule. Empirical rule with normal curve. And hit images and copy the best one that you like. I usually pick one that's got everything on it that doesn't have a line going through the middle. I can't find one right now. This is good. It's got I like to have one with 0, 1, 2, 3 on the bottom. But pick one that you like. Here's one. That's a good one. Pick one that you like. Copy it over to a word processor. Put 6 to 8 on a page. And copy 10 copies of it, and then you'll have plenty of these drawn, unless you want to draw every one of them. I like this one or this one. I like these. So that's something you can work on for homework. Now you should be able to work on 3.1, 3.2, and maybe 3.3, but I don't know. Okay, now I'm going to check. Did anybody come in to the class? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Somebody came in. Who came in? Who came in late? Okay, nobody's going to
Me.
Okay, give me your last name. I'm sorry.
Glenn.
Okay, Glenn came in late. Who else? Somebody else came in late. Simmons or Stewart? Simmons came in late. Anybody else? Let's say Stewart. Did Stewart come in late? Nope. And it still won't let me save it. Okay, y'all can skedaddle. I got y'all down, and I'm going to turn off the recorder and the presentation. If you got questions, hang around. If not, see y'all Wednesday. Remember, get Teams downloaded also. See y'all.